northern plains all the way down to the Gulf. Yes, this is dangerous, a life-threatening cold, and we have winter alerts now draped across much of the country. We're talking coast to coast plains all.
So hello and welcome here to our exhibitors forum. Our next speaker is Casey Young from Cadence, and he will be talking about easy and fast deployment of an AI noise reduction algorithm on HiFi DSPs. Welcome.
Okay. Thank you for coming today. Today I want to talk about how to very quickly deploy AI noise reduction using the new Tensilica HiFi Audio Development Platform. So the Tensilica HiFi Audio Development Platform, called it ADP. So ADP is actually here. So it is a carrier PCB with an SoC module, and the SoC module has a Cadence DSP inside. So the ADP runs a software called the DSP Concepts AudioWeaver, and I'll talk about it later, to simplify implementations. So right now I'm showing is the SoC is from a company called Aroha, and it is actually one of the very high performance HiFi 5 and a Bluetooth chip. So some of the leading TWS and headphones are using the Aroha HiFi 5 Bluetooth SoC. So to make things simplified, the Bluetooth firmware on the ADP is pre-configured. So as if you ever develop audio products or think about developing a speaker or a Bluetooth headset, just solving the Bluetooth firmware problems is a big undertaking. And you don't want to really spend too much time trying to worry about this if you are an audio software developer. So what we are doing is that the Bluetooth firmware is pre-configured, so you don't have to worry about it. And all you need to do is to focus on the audio software. And that's what ADP is for. So in one of the example, I'm going to show you how easy to just deploy an AI algorithms to the ADP and without programming. So this is a breakdown of what is on the ADP. So the carrier board, it will be a fixed board. And in the future, different audio modules or the different SoC, they go to the little carrier card. So the carrier card will actually be offered in multiple SoCs. So today we start with two flavors, the HiFi 5 and the HiFi Mini SoC, both from Aroha. So the baseboard provides all the I/O connectors for power supply, for debug, for audio input and audio output to facilitate development work. So this is the block diagram of the ATP. So as you see, you have the UART, you have the audio in-out, I2S input-output. We have the key controllers, we have touchpad, we have JTAG, we have test and control blocks. So everything that you need to develop is on the ADP. Okay. So what happens is after you develop your software algorithms on the ADP, it can quickly be deployed into actual hardware modules. For most of the productions that if you are not making millions and millions of products, it could be cheaper just to build your software on ADP and deploy on one of the modules. So the modules can be soldered into the actual product circuit board. So for example, there's two modules available for the these HiFi 5 modules. One of them is more of a square stem size, and that can be used like in a smart speaker or a headphone. The other one is a narrow profile, and it can be integrated into like a smart glasses. And it's all pre-built and pre-qualified, so you do not need to spend a great deal of effort to do like all the RF testings and the compliance testing. But for really high volume products, with all the software pre-built, it becomes your proof of concept, and you can use this to target customers and then take this into specific form factors. So you can build a PCB with the SoC, but all the software has been proven, and once the PCB is built, you can simply migrate the software into the specific product. So as I mentioned, what we try to do is, by using this system, we try to lower the barrier of audio software development, sort of making this like a Raspberry Pi to develop different applications with very low effort and very easy and not to worry about spending a lot of upfront investment in creating a custom hardware platform. Are you any of this? You guys are developing audio software or audio products? Okay, I know one. I know Stefan. Okay, so it's always a challenge when you have an audio software in mind. But where do you put your audio software? Right, you need to have a form factor. You need to have something, and to get a board from an SoC vendor to send you a chip, you may need to have a platform to work on it, right? So now we are providing a ready-to-go platform, and you can turn it on within 1 hour and start working on the audio. So what happens is it allows the software developers to quickly take their concept and their idea, and they can actually play and listen to it. So they can go into an OEM customers and try to promote their product and concepts. Now, as an OEM customer, they can validate your audio idea without building expensive prototypes. And so they can quickly make a decision and take product to market. So instead of running it linearly, first you find an SoC, then you build a hardware, and then you start doing the software, and later you have a prototype, and then you start trying to do marketing. We can shorten the whole process. So, as I mentioned before, the ADP is preloaded with AudioWeaver by DSP Concepts. DSP Concepts is one of Cadence DSP software partners. So they develop an AudioWeaver software. The AudioWeaver allows you to design audio signal flow graphically with building blocks that's already pre-configured. So you do not need to really do any programming. And it is already optimized and target specific for each of the HiFi cores. So it allows you to tune the audio in real time on the PC, running Windows, and you hear the effect, and you can transfer the whole audio signal flow onto the HiFi 5 ADP. And later, when you have the module or product that is specifically running the same SoC, you can transfer the same audio flow into your actual product. Now, if you are an advanced software algorithm developer, you can build your own custom IP with the AudioWeaver. So what happens is that your proprietary algorithms becomes a building block into the AudioWeaver, and then you can use a mouse to drag and drop your custom module into the audio signal flow. So this is an example. So this depicts a audio signal flow. It looks very complicated, but actually it's like building a PowerPoint. So any of these functioning blocks can be drag and drop into your signal path, and you can configure any of this signal path that's pre-configured. So if you need a filter or you need an equalizer, it's all there. You don't have to write C and build something. So this, on the left, it shows all of the available modules that you can drag and drop into the signal flow. And then by double-clicking any of these modules, you can actually configure the modules without programming, basically. So as you can see, traditionally, for an audio software developer, before they can develop some useful audio demo, they have to have a hardware platform. And it takes time and energy to try to find a hardware platform and before they can build their audio software. So without the hardware, you really can't do anything. But what we are trying to do is we provide the ready-to-go hardware so that you can start building the audio software first, instead of building the hardware first. As I have a lot of background in building hardware and software products, typically when you have a concept, taking a concept to a product takes anywhere from 6 to 18 months, because you have to build hardware, you have to build toolings, you have to have the exact physical profile before you can even tune your audio. But starting with an ADP, we believe that you can shorten the development cycle to 4 months before you can even actually do real-time audio tunings. So for the software developer, the ADP can dramatically and drastically shrink non-audio overhead because all the firmware on the hardware is pre-configured. So you can allow you to straight away go into real-time audio development. You can have the audio performance and tuning for immediate results. So it shortens the time to market. You can have a working POC of your audio software in a very short time. For device maker and OEMs, they can actually lower their hardware engineering effort and risk because they can start their product design and the concept without having to deal with all the RFI and the Bluetooth design, which are actually complicated for many of these hardware developers or OEMs. So it allows them to really quickly do a POC to test the market. And then they also do not need to wait for a long time for the audio software to be completed, because the audio development can start at the same time in parallel. So it basically shortened the time to market. And the audio algorithms can still be modified when the product is ready, because you can tune it independent of the hardware. So this is a proposed pricing. The baseboard for $150 US, and the modules or the carrier board will be $50. The hardware is developed and promoted and marketed by one of our partners, Asia Universal. So that is, if with any interest, so contact sales@asiauniversal.com. Sorry, they have the PowerPoint that has the old email address. Okay. The representative of Asia Universal is here, as well as in our booth. So if you have actual interest, please come to see any of us after the presentation or anytime during the show. Now I want to talk about how simple it is to deploy an AI-based noise reduction using the ADP. The AI-based noise reduction is provided by one of the Cadence software partner called AI-Zip. Why do we need to care about AI-based noise reduction? So we heard about all this AI and all the good stuff about ChatGPT, but actually you can be using AI in a very low cost, very easy in one of these audio products. So the AI provides the noise reduction and is better than the traditional noise reduction running with the DSP. Why? Because, first of all, the traditional beamforming is not a good fit if you have a diffuse sound field. Because the beamforming has two microphones, and it points to one direction. So you're trying to reject noise coming from different directions. But what if the noise is all over? Then the beamforming does not work, right? So a diffuse sound field is not good, trying to solve this problem with beamforming. Now, another problem that you cannot solve with beamforming is that if the noise is very loud, such as you are driving with your windows down, or there's a very strong wind. So the extremely noisy environment, beamforming does not work. Then the other thing that you cannot resolve is the residual noise, like your signal-noise ratio of your device actually, or the humming in the electronics. You cannot solve it with the beamforming because it's not, the noise is not from the microphone. Right? So we can do this with an AI-based noise reduction because, as you all know, you can specifically train for the specific noise that you're trying to get rid of. So with some advanced algorithms, or with our partners like AIZip, they can specifically get rid of certain noise. So if you are looking at the industrial applications, like a driver driving a fire engine, and we want to eliminate that specific siren, we can take that sample of that siren and train it, and we can put it into a headset to remove that specific noise. So that's the beauty of the AI-based noise reduction. So this is a typical block diagram of AI-based noise reduction. The strength of each of the companies marketing different AI-based reduction basically is on how they create the model and how they train. But the basic concept is everybody is almost the same, right? So you are competing not on the signal flow, but on how strong is your model and how small it can be reduced and how little resource it takes to get the best effect. Because we are not running from the cloud. We are running in a headset that has very little memories and consume very little battery power. Right? So this is an example of how good AI-based noise reduction can be applied, okay?
It was because here in this land, we unleashed the energy and individual genius of man to a greater extent than has ever been done before. Freedom and the dignity of the individual have been more available and assured here than in any other place on earth. The price for this freedom at times has been high, but we have never been unwilling to pay that price. Those who say that we're in a time when there are no heroes.
I think, okay, let's start again. Let's play this one first. This is a windy sample, okay?
With its row upon row of simple white markers bearing crosses or stars of David, they add up to only a tiny fraction of the price.
So this is the speech sample, with the original speech sample with the background noise.
Each one of those markers is a monument.
I think there's a messed up with two samples playing at the same time. Okay. Let's give it one more try. If not, you can come to our booth.
Across much of the country.
Okay.
We're talking coast to coast,
This
from
is
the northern
okay.
plains all
This
the
is
way down to
this
the
is clean up. There's all the wind noise has been removed. Okay.
And halfway around the world on Guadalcanal, Tarawa, Pork Chop Hill, the Chosin Reservoir, and in 100 rice paddies and jungles. If we look to the answer as to why for so many years we achieved so much, prospered as no other people on earth, it was because...
Okay, so you hear all the background on the speech has been removed, and this all done with the AIZip algorithms. And basically you can have the similar effect running it in a little headset or very easily prototype to the ADP. So I actually will show you a little bit here, the actual product. So this is AudioWeaver running. And right now it shows a template of a Bluetooth headset. And it's actually playing a piece of wave file as though it's playing music from a Bluetooth headset. So you can actually see a real-time VU meter running and showing demonstrating the volume level of the audio signal. So we stop the music. And with the AI zip, actually, it got wrapped into a module. So any of the third parties, like you are trying to license, whether it's 3D immersive audio or AI noise reduction or beamforming, it becomes a module, and you can just drag and drop into the signal path, right? And then all you do is you can connect the signal flow, and you wire in, and you can hear the effect through your windows. And when you're happy with what you hear, we change the target from Windows to the ADP, and you can drop it in with the RS-232 interface or even with the Bluetooth. And to take this one step further, when you build the prototype, it has the same thing. So your actual speaker or your actual wireless microphone or your TWS behave the same way. Okay. So that kind of concludes the end of my presentations. So open for any Q&A. Yes, please.
Is this also available for the HiFi 4 DSP? Or?
We could, except that if we find a target like a Bluetooth chip with a HiFi 4, we could do that. So we have an upcoming HiFi 4. It's not recommended for headphones, but you can build speakers because that SoC is not the best for conserving battery power. Okay. Hi, Stefan.
Thank you for the presentation. Quick question. You mentioned over-the-air firmware updates to deploy new versions of an algorithm. Wondering how this is working, via which channel, if there's some protection on it, because it might be very nice to have a good interaction with the customer.
Yes, you're talking about the encrypting the algorithms.
Yeah, so basically, if we develop something, we deploy it for a customer, he wants to test a new version, and we just say like, take this one, try it out.
Yes. So you can send a package that he cannot see what's inside, right? So they can, but as part of the DSP core, we do not have control on protecting just the DSP binary. So you have to you can only protect the whole binary, including the firmware of the Bluetooth. So unfortunately, that's what's happening today.
Okay. And then a quick second question for the AI enhancement that we just saw that was completely programmed in DSP Weaver? Or was it like programmed in C and then packaged?
It is programmed in C and then attached to a specific API recommended by AudioWeaver so that it can be plug and play. Okay. And there is actually a specific reference and instruction on how to wrap that. So depending on the type and business arrangements, you can be doing it yourself and drop it in, or you can work with the DSP Concept to make this available to all of their customers across all platforms.
Thank you.
Anyone else? All right. Thank you for coming and enjoy the rest of your Embedded World. And do come to the end of the day Embedded World invitation if you are invited. And also come to see us in the Cadence booth, Hall 4, number 219, and you can actually see and talk more about this platform that we discussed today. Thank you.